Hey everyone, where are we?
We are hovering high above the planet Earth, looking down on what's probably North America and specifically South America, where we're going to go to the Amazon.
And the reason we want to go to the Amazon is to look at how a river system begins and develops, and this looks like the Amazon River.
It does not quite look like the Amazon River yet. It looks like a big mountain leading down to a tributary of the Amazon River.
So on each of the mountain sides here, we can see there's a lot of rills, there's a lot of gullies, there's lots of down cutting from rain, eroding the land, breaking down the rock, and moving that rock down to lower elevations. If you want to look at our first elevation here, we are at 8,929 feet above where the river wants to go, which is
0 feet sea level.
Sea level. So let's go to the next part. After we go down those little rills and gullies, we get down to where tributaries kind of feed into the much larger stream.
Right, and you can see it right there. There is definitely a tributary leading into a larger stream, which, if you look very closely here, you can see a lot of white water on. White water indicates rapids, which means that the river is flowing quickly.
So if it's flowing quickly, that means it's not too wide, it's not too very skinny, it's narrow, and we've got fast-moving water here. Where one body of water meets another, we call that a confluence. Let's see if we can find evidence of more downcutting and aging streams.
We definitely see more rapids here. We definitely see a very steep cliff wall. It's very much like what we just looked at. So the river is still relatively youthful, pretty straight, not too many curves.
Well, young rivers can curve.
They do curve all the time.
Not only old rivers are not the only ones to curve, we can see that happen in young rivers as well. So our elevation check here, we're now at around 5,900 feet. We've dropped about 300 feet in just a few hundred miles of flight.
So here we're dropping into another area that is very evidently downcutting.
What do you mean by downcutting?
What I mean by downcutting is when a river is flowing fast, it has a lot of energy. It has energy to move through things as opposed to around things. And because of that, you end up getting this sawing action. Someone mentioned at one point a knife through butter.
So the fast-moving water, again, goes around the rock, but also has the ability to cut through the rock and create these sheer cliffs on either side. And an elevation check at this location, we're now at 4,900 feet above sea level. Let's go see if we can find a more mature river, an older river that has some different features.
So what that generally means is flying down to an area where you're further down the mountain, possibly in another stream or at least leading into another stream because you're in a lower area. The water's now meandering more.
What does it mean to meander again?
It means to make curves, in other words, to wander back and forth. And you can see here that there's deposition and erosion. On the outside of the curves, you get erosion. On the inside, you get laying down of the sediment, which is deposition. And you can see the floodplain is actually getting bigger.
So we get this winding, we get another confluence here. The rivers become wider and more mature. Like you said, they start to go around bends, and you can see the sediments that are dropped off on the inside of curves and the erosion that occurs on the outside of curves. So based on the speed of the water, because water is a fluid trying to move all together, everyone trying to keep up, just like the horses on a merry-go-round, the outside moves the fastest. And checking our elevation here, we are now at 2,200 feet above sea level. So we've dropped again another 2,000 feet or so. However, we're not dropping as quickly as we did in the beginning. Let's go to some more mature parts of the stream. You can see it wandering and meandering as we fly to it. What are we seeing here?
And you're definitely getting some braiding. And what braiding is when a stream kind of wraps around the sediments that are choking the stream off because things are slowing down. The water can't break through those sediments, and therefore it has to go around them. And you get this pattern of, well, it's very much like braids in a person's hair.
So this would be more of a floodplain. This is extremely wide. And what do people do in these areas?
They love to plant things.
And why would they like to do that?
Whenever a stream floods, it carries a lot of nutrients to the ground around it. So it makes the area very fertile. And because of that, people like to plant around them. And even though it poses a hazard to their homes, they're okay with that because they know they get a great return on it for their crops.
Elevation check here. We're at 1,072 feet above sea level. Let's go a little bit more mature in our stream as we wander, and you can see it meandering. Got some severe meandering happening.
It's meandering so much that the water may want to stay on its path. So you end up with sort of this inertia problem where the water wants to go straight through instead of around the curve, and eventually will break through. They call these very winding meanders like this oxbows.
And you can see again deposition on the inside of the curve and erosion happening on the outside of the curve, and eventually those two areas can erode so much that they actually will meet, and the water will decide not to go around this big bend. It'll just go straight.
And if it does that, it'll leave that piece all by itself, which makes something called an oxbow lake.
And where are we seeing these oxbow lakes?
I see them all over the place. On maps like this, very dark water, like the black stripes that we see here on this image, is still water. And that means that those are meanders that were broken off of the original river channel and now are sitting alone as lakes, and so they call them oxbow lakes.
So the river has cut itself in. You can see another oxbow is probably going to form right here in the middle. But there are many, many of these as the river is very mature now, very wide, carrying lots of sediments, lots of erosion and deposition happening in lots of locations.
And the floodplain is huge, and the reason that that's happening is because this river now has been winding back and forth hundreds of miles by breaking off meanders and forming oxbows, changing directions, going around sediments. It has basically worn away the mountains.
To this area, we traveled hundreds and hundreds of miles, but we've only dropped a few hundred feet. So we're not dropping as rapidly as we did before. The elevation drops are much lower, so that must mean that the water is moving much slower.
And we can only drop another 364 feet
before we get to
this
our
place.
delta. So here we are at the end of our river here. Again, it looks like we've got those braids happening again where the water, like you said, gets choked by its sediments and spreads out into all these little fingers and braids, and instead of tributaries, they're now distributaries.
Which basically are giving the water back to the area as opposed to taking it away.
And you can see our elevation around here. I'm getting about 10 feet above sea level in some of these locations. So we are right here meeting the ocean water, so fresh water from the land meets the salty water from the ocean.
It feeds back into the hydrologic cycle.
There you go. So we've taken you from the beginning of a river high in the mountains with fast moving streams through the more wider mature streams that carry more sediments, start to wind more, and you can see as I follow my cursor here, there is the entire Amazon River going the width of the country of South America.
And there you have it.